and welcome back. We're going to start off with the geology section of Earth Science. That is our largest section that we're going to study, and it will continue on for the rest of the semester. Today we're going to start off with the chemistry behind minerals. First of all, let's start off with the concept of matter. Matter is anything that has mass and volume. In other words, it has mass and it takes up space. Everything in the universe is composed of matter. Matter is made up of atoms, which are the smallest part of an element that still has all of the element's properties. Elements are substances that cannot be changed into simpler substances by chemical reactions. And as you can see here, elements are organized on a table called the periodic table. The nucleus of an atom contains charged particles called protons, which are positively charged, and neutrally charged particles called neutrons. The nucleus, together with those protons and neutrons, makes up more than 99.9% of an atom's mass. Much smaller negatively charged particles called electrons orbit the nucleus, much as the planets orbit the sun in our solar system. The nucleus is tiny, so the vast majority of an atom is empty space. The number of protons in an atom's nucleus is equivalent to the atomic number. It is this number that dictates what element the atom is. So it's not the neutrons, it's the protons. It's not the electrons, it's the protons. The mass number is the number of protons and neutrons in an atom's nucleus. The number is usually larger than the atomic number. There's only one exception to that, and that is helium, because helium does not contain a neutron in its normal state. The number of neutrons equals the mass number minus the atomic number. Now, when you're calculating these, you actually round up. So for titanium, you would round up to 48 as the mass number, subtract 22, and that gives you 26 neutrons. Isotopes are different forms of an element. They only differ in the number of neutrons in the atom's nucleus. The number of protons remains the same. Ions are where the neutrons and protons stay the same, but the number of electrons changes. So if an atom loses electrons, it becomes a positively charged ion. If it gains electrons, it becomes a negatively charged ion. Several elements can form compounds once they're combined, and compounds are substances composed of two or more elements. The smallest chunk of a compound is a molecule. Okay, so those are the very basics of chemistry that goes into minerals. So let's talk about what minerals actually are. There are 5 requirements that define what a mineral is. First of all, minerals must occur naturally. Minerals must be solids. Minerals have definite chemical compositions. That means elements in definite chemical proportions. Minerals must have atoms that are arranged in an orderly pattern, usually crystalline in lattice form. And minerals are also inorganic. In other words, they're not formed by plant or animal activities. Native minerals are minerals that are made of only one kind of element. In the case on this picture, it's copper, but titanium could be a native mineral. Gold is a native mineral. Those are the kinds of things. And usually when you think of metals, they're very often native minerals. Most elements that are minerals are also metals. And metals are good conductors of heat and electricity. However, many minerals are also nonmetals. Nonmetals are good insulators of electricity and are on the right-hand side of the periodic table. This is a mineral called sulfur. Minerals can form in several ways. The 2 primary ways that minerals can form is from the cooling of magma in underground chambers and its corollary, which is the cooling of lava on the surface, And the second way in minerals that form typically are from the evaporations of ancient lakes and seas. Minerals often form into regular shaped solids called crystals. Crystals have smooth faces and have a regular geometry to them. Almost all of the minerals on the planet are silicates. These are composed of silica tetrahedrons, and you can see the most basic form in the upper left. Silica tetrahedrons are made up of one silicon atom bonded covalently to 4 oxygen atoms to form a tetrahedron that is perfectly symmetrical. This is one of the most abundant molecules of the Earth's crust, and it is what is primarily what we stand on today. Okay, so that's a very basic introduction to the chemistry behind minerals and an introduction to what minerals are. Make sure that you understand the 5 characteristic requirements of minerals for it to be one, understand what native elements are, and understand what silicates are. Okay, you have a fantastic day. If you have any questions, as always, please see me during office hours or send me an email. Have a great day.